Hello everyone, my name is Johannes Laurmaa, and today I'll be presenting my research on the automatic prediction of grammatical cases in case marking languages. Work I initially developed for template filling applications. While this approach is applicable to all case marking languages, I'll be focusing on implementation details specifically for the Finnish language. This project started with a straightforward business application in mind, template filling. Template filling is probably one of the simplest NLP techniques, if you can even call it NLP. So imagine you're a business sending information to your clients, here for instance sending booking information via email. Super easy, you just set up a template sentence with placeholders. During inference time, you just plug in the user's specific information, the recipient's first name, the destination city, the date, etc. And you have an email ready to be sent. It's not flexible at all, but it is simple and it works. So this is why templates are still used basically everywhere today. Template filling works very well in English. However, it is terrible for some highly inflected languages like Finnish. You can't directly insert nouns into the templates because the nouns have to be inflected to the right grammatical case first. In this example sentence here, in English, we indicate a movement towards the city using the preposition to. That works irrespective of the noun you use. But in Finnish, the meaning of movement towards the city is embedded into the noun. So the noun has to be inflected to the illative case before being inserted into the sentence. In this case, you would inflect the word Helsinki to Helsinkiin. Automating this kind of template filling is not trivial. You can't really use rule-based methods because the grammatical case really depends on the context. And that's the challenge for which I will present a solution today. Before we proceed, just some quick background information for those who are not familiar with word inflections. In English, you never really modify nouns, you simply add prepositions around them to produce the desired meaning. But in highly inflected languages, like Finnish, Czech, Hungarian, you will modify the noun itself depending on the context. So here's a list of 15 cases that we use in Finnish. The word talo, which means a house, can get various different meanings depending on how it's inflected. So talo simply means a house in the nominative case, but talossa means to be in the house, taloksi means something transforms into a house, etc. So the grammatical case you need to use really depends on the meaning you want to convey. The main contributions of our research are the following. First, we formalize the case detection problem in two different settings. The slot-only setting, where you only see the template sentence containing an empty placeholder. You don't know in advance which word will replace the placeholder yet. The second setting is the lemma-conditioned one. In this setting, you know which word will be used in the end. In the shown example, we know Helsinki will be the one we want to place in the template. Second contribution, we provide a recipe to generate training and evaluation dataset out of any raw text in the given language. All you need is a morphological analyzer recognizing the case of inflected words. And finally, third contribution, we train and publish transformer models for the case prediction task. In a real-world template filling scenario, what you ultimately care about is to have a grammatically correct sentence at the output. We achieve this through the prediction of the grammatical case, thanks to our trained transformer model in a first step. After which, you then use existing morphological generators to inflect the noun to the case you just predicted. Morphological generators are readily available, at least for the Finnish language. So here is the recipe we use to create training and evaluation data for our task. First, we get some raw text in the relevant language and domain. Second, we use a morphological analyzer to extract the lemma and the case of the nouns in the text. And third, we create the samples, selecting random nouns as targets. We either mask them for the slot-only setting or replace them by their base forms for the lemma-conditioned setting. We fine-tune two types of models, XLM Roberta, which was pre-trained on multilingual texts, Finbert, which was pre-trained on Finnish texts. As dataset, we used news from the Finnish National Broadcasting Company, using 2019 data for training and 2021 data for testing. There wasn't really any good existing baseline available for this task, so we came up with two baselines based on heuristics. First, majority class, simply predicting the top categories. And second one is a baseline based on adpositions. If there are prepositions or postpositions around the noun, we map it to the related grammatical case. Otherwise, we default to the majority class. Also, note that there's some aleatoric uncertainty in our case detection problem. This is because multiple predictions can produce grammatically correct results, as shown in the example below. The context often gives us good clues, but we cannot always say for sure which one matches the true writer's intent. Now let's have a look at the results, the main performance metrics of our trained transformer models. First, the low performance of baselines show the complexity of this task. Our models achieve a pretty good performance, although we can get too close to 100% due to the aleatoric uncertainty mentioned earlier. We observe that the monolingual models perform better than the multilingual XLM Roberta, and we can also see that providing the lemma during inference time, so the lemma-conditioned setting, helps significantly compared to the slot-only setting. Let's look a bit closer at the performance difference between slot-only and lemma-conditioned settings. Providing the lemma helps disambiguate between possible cases. For example, knowing that a placeholder will contain a city name would probably suggest the use of locative cases. In some sentences, the correct case might also depend on the noun itself. Some nouns are often used with internal locative cases, inessive, elative, illative, while others are often used with external locative cases, adessive, ablative, and elative. This is why these case pairs are often confused together in the slot-only setting. Before we wrap up, why don't we simply use LLMs for this task? LLMs are indeed trained to form grammatically correct sentences, so they could be used for this task too. However, our experiments show that they don't perform necessarily better than transformer models. They are also heavier, and they might even be too flexible when the user just wants the predictability of a fixed template that produces always fixed outputs. Off-the-shelf LLMs also just produce a single truth and not always probabilistic outputs, which could be useful in some use cases. To sum up, we formalized the case detection problem for template filling use cases. We provided a recipe for the automatic construction of a dataset from raw text. We trained transformer models predicting cases in Finnish sentences. Some next steps could include defining the upper bound on achievable performance, applying this recipe to other languages and domains, and handling multi-slot predictions, since predicting them separately might not ensure global consistency. Thank you for listening. If you have any questions or suggestions, please reach out. You'll find the links to the code, the Hugging Face models, and my contact information on this slide.